Big news in the world of science. The 2025 Nobel Prize in Chemistry has just been announced, and it's for something that could literally change everything. We're talking about building our world, one molecule at a time. So let's dive in and see what this is all about.
Okay, so to wrap your head around this, the Nobel Committee came up with this really great analogy. They said to think of these new materials as a hotel, but for molecules. Seriously. Imagine a structure with all these tiny, perfectly designed rooms where specific guest molecules, like say a water molecule or a toxic chemical, can check in and then check out again. It's a wild idea, right? And it's the key to understanding why this is such a huge deal.
So yeah, this year's prize is all about celebrating the architects behind a whole new class of materials. The official name is Metal Organic Frameworks, or MOFs for short. Now, let's meet the brilliant minds who actually built this new molecular world. All right, so the prize is shared by three absolute pioneers. We've got Susumu Kitagawa from Kyoto University, Richard Robson over at the University of Melbourne, and Omar M. Yaghi from the University of California, Berkeley. It was their work stretching over decades that really laid the groundwork for this whole new branch of chemistry. And for all that hard work, they'll be sharing a prize of 11 million Swedish kroner, which comes out to about 1.17 million US dollars. Not bad, right? But honestly, as we're out to see, the real prize here isn't the money. It's the incredible future this discovery unlocks for all of us. Okay, so what are these things? Let's get into the science. And you know what? There's another fantastic analogy for this. If you're a Harry Potter fan, think of Hermione's magical handbag. You know, the one that's tiny on the outside, but you can fit practically anything inside. That's basically what a metal organic framework is like. It's all about that massive internal space. So the official definition is that MOFs are crystalline materials. All that means is that they have this perfectly ordered, repeating structure, kind of like a microscopic jungle gym or a scaffold. They're built from just two key parts. You've got metal ions, which act like the joints or corners, and then you have these carbon-based molecules that act as the long poles connecting everything. When they all link up, you get the structure that's mostly empty space, super, super porous. That's where you get all those hotel rooms we were talking about. So, how do you even build something like this? Well, this is where it gets really cool. The process is actually kind of elegant. You start with the metal parts, the nodes, then you add the carbon-based linkers that are designed to connect them, and then you just let them do their thing. This is the magic part. It's called self-assembly. You don't have to put them together one by one. The pieces just spontaneously click into place, forming this perfect, stable structure all on their own. It's like Legos that build themselves. It's incredible. Now, this kind of breakthrough, it definitely didn't happen overnight. Not even close. We're talking about a really long, tough journey that took like 15 years to figure out. It wasn't one of those eureka moments in a lab. Nope. This was all about pure persistence, people working together and building on each other's successes and failures over a very long time. Let's rewind to 1989. That's when Dr. Robson first showed, hey, this is possible. He made a crystal structure with these big empty spaces inside. But there was a huge problem. It was super unstable. It would just collapse almost immediately. So for the next decade, Dr. Kitagawa and Dr. Yaghi picked up where he left off. They worked and worked until they finally cracked the code on how to make these things not just porous, but permanently porous and strong. They turned a fragile little lab curiosity into a whole new class of revolutionary materials. And to really get why this is such a game changer, you have to appreciate the massive hurdle they cleared. I mean, for chemists, trying to get molecules to arrange themselves in a specific, predictable way, that's been the holy grail for centuries. Usually, they just clump together in a random mess. But these guys? They became true molecular architects. They designed the building blocks so perfectly that they would assemble exactly the way they wanted them to. That kind of control, it was basically science fiction until they did it. Okay, so we've got the science down, but why should you care? What does this mean for us in the real world? How could these little molecular hotels actually change our lives? Let's get into it. Honestly, the possibilities here are just mind-blowing. I mean, just imagine a device filled with these MOFs that are perfectly designed to grab water molecules right out of the air in the middle of a desert, creating water from thin air. Or think about water filters that can specifically target and snatch out nasty toxic chemicals, making our water safer.
Even something simple like a container for your fruit that uses MOFs to trap the gas that makes them ripen so they stay fresh way longer and we waste less food. You see, this isn't just one new thing, it's like a master key that's unlocked thousands of new doors in chemistry. Behind every one of these huge scientific discoveries, there are always some really amazing human stories. We know what they built, so now let's get to know the architects themselves a little bit. So picture this. Dr. Kitagawa gets the call, the one from the Nobel Committee, and he almost hangs up on them. He said he'd been getting so many annoying sales calls that he answered the phone in a really bad mood, totally expecting it to be another telemarketer. Can you imagine? It's just a great little reminder that these Nobel laureates are real people. And then there's Dr. Omar Yaghi's story, which is just, wow. It's a story of incredible perseverance. He was born to Palestinian refugees in Jordan, and he grew up in a home where his family could barely read or write. I mean, he actually shared a room with the family's cattle. From there, he made his way to the United States for college, worked his way through the public university system, and rose all the way to the absolute top of his field. It's just an amazing journey. And his story really gives this quote from him so much power. He said, "Science is the greatest equalizing force in the world. Smart people, talented people, skilled people exist everywhere." I mean, if his own life isn't proof of that, I don't know what is. It just shows that talent is everywhere, and given a chance, it can truly change the world. So if you remember one thing from all of this, let it be this. For the first time ever, scientists aren't just finding new materials, they're building them from scratch, atom by atom. They can now design and create structures that have properties we used to think were flat out impossible. This isn't just an improvement, it's a whole new era for science. And that leaves us with one final, pretty exciting question to think about. We now have materials that can literally build themselves. So, what's the next impossible problem we're going to solve?